Yeah. Okay. So write down question today's question. First question: How many silver coins? How many silver coins? How many silver coins? 1.75 centimeters in diameter. 1.75 centimeter in diameter. This is the diameter given. D is equal to 1.75 centimeters in diameter of thickness. Thickness is given as 2 mm, 2 millimeter thickness given. Okay, must be melted to form a cuboid of dimension 5.5 centimeter into 10 centimeter into 10 centimeter into 3.5 centimeter. So question is clear, I think. There are silver coins, and these silver coins are to be melted, and after melting these silver coins you have to form a cuboid. The dimension of the cuboid is given. The question is how many silver coins will be required to form a cuboid of this dimension. This is the dimension of the cuboid, and this is the dimension of the coin. How many coins will be required? Question is clear, I think. Let's see the solution now. The solution says that when you see what is same here, the volume of silver that is being used to melt all the coins, the volume of all the coins should be equal to the volume of cuboid, isn't it? Write down. When when coins are melted, when coins are melted to form a cuboid, when coins are melted to form a cuboid, the volume of all the coins, the volume of all the coins should be equal to should be equal to the volume of cuboids, is equal to the volume of cuboid. The volume of all the coins should be equal to the volume of cuboid. Full stop. Then write down. Let there be let there be let there be n coins. Let there be n coins melted to form the cuboid. Melted to form the cuboid. Therefore, n into volume of coin is equal to volume of cuboid. N into volume of cuboid. Is it okay? N into volume of coin is equal to volume of cuboid. This point is clear? Right. Now let's see here what is the value of n. N is equal to volume of cuboid upon volume of coin. This point is clear. Cross multiply, this will go down. So volume of cuboid upon volume of coin. What is the volume of cuboid? Length into breadth into height. That is equal to 5.5 centimeter into 10 centimeter into 3.5 centimeter divided by the volume of coin. Now you see the coin is circular and has also got height. So coin, the shape of the coin is just like a cylinder. The shape of the coin is just like a small cylinder, right? So that is, it is cylindrical, so its volume will be pi r square h. So volume will be pi r square into h, where the value of r is equal to, this is given as diameter. So the value of r is 1.75 by 2 centimeter, and the height is equal to 2 millimeter. That means 2 upon 10 centimeter. This point is okay. So place the value of r and also the value of h. Place the value of r and also the value of h, right? So what you will get here, r and here h, and the value of pi is 22 by 7. Because the value of pi is not given in the question, so you have to take 22 by 7. So this is going to give you 5.5 centimeter. All are in centimeters now, so we will write it later on. 3.5, all are in centimeters, so that will be centimeter cube. You can write here also, it will be pi is 22 by 7. Radius is 1.75 upon 2 into 1.75 upon 2 into h is given as 2 upon 10 centimeters. All are in centimeters. This is also in centimeter cube. This is also in centimeter cube. So this centimeter cube will be cancelled. Now you see here 7 is here. So 7 you can cancel this. 7 can be cancelled here. You will get how much? 2.5. 0.25. And this 2 will be cancelled out here. This here you can cancel here 11 times, and this you can cancel here 2. 1 is 2. Now 7 will be cancelled here, this, and you will get here 0.25. Right? So as a result, now what you are getting in numerator? 5.5 into 10 into 3.5, and in denominator what you are getting? 11 from here, 0.25 from here, and 1.75, and this cancelled to 10 is going to go up in the numerator. The denominator, this is the denominator, and denominator's denominator, it will go up, it will become numerator. So into 10. Now decimal you can remove here, and here is one place of decimal, and this is one place of decimal. Two place of decimal here, two place of decimal here, cancel out. Decimal will be removed here, two place again, two zeros will be increased here. It becomes 1000. 11 you can cancel here, 11 5 is the 55. Check the calculation part. 5 ones are 5, 5, 5 is a 25. 5 you can cancel here, 5 2 is a 10. Right? So this was 1 here, this was 2. Now 1.75. So you can cancel it here. Here you can cancel. Hmm? 35 into 5. 5 is 15 for 25. 35 into 5 is equal to 175. This is what? 35. 35 into 5 is equal to 175. So this will be cancelled here how many times? 5 times. 5 cancelled here, 5 to the 10 here, 200. 200 into 2, that will give you 400. Total how many? 400 coins will be uh, required to be melted to form a cuboid of this given shape. Right? Answer write down. Answer 400 coins. Answer 400 coins will be required to be melted to form a cuboid of the given dimension. How many coins? 400 coins will be required to um, form a cuboid of the given dimension. Okay, then those who have joined late, please listen to the question and see the solution. How many silver coins 1.75 centimeter in diameter and of thickness 2 millimeters must be melted to form a cuboid of dimension 5.5 centimeter into 10 centimeter into 3.5 centimeter? So there are some large number of coins, and these coins are being melted, and after melting them they are forming a cuboid. After melting them they are forming a cuboid, and the question is how many coins will be melted to form a cuboid? The question is how many coins will be melted to form a cuboid. So here you see the dimension of the coin is given as its diameter is 1.5 centimeter, 1.75 centimeter, and the thickness of the coin is given as 2 millimeters. Now it is melted to form a cuboid. This is the dimension of the cuboid. This is the cuboid. Length is this, breadth is this, height is this. So here n times the volume of the coins, of whatever coins are melted to form this cuboid, should be equal to the volume of the cuboid. So n is equal to volume of cuboid upon volume of coin. Volume of cuboid is length into breadth into height, and the cuboid and the coin is pi r square h, because coin is like this type, cylindrical in shape. The coin is cylindrical in shape like this way. Okay, this is the shape of the coin. So this is the radius of the coin, and this is the height of the coin. So this is radius here, and this is the height of the coin. So here you see this coin has got the dimension, the diameter is this, so its radius will be this, and height is 2 millimeters, that means 2 upon 10 centimeters. All the measurements are in centimeters now. So n is equal to volume of the cuboid divided by volume of the coin. So this is the volume of the cuboid, and this is the volume of the coin, pi r square h. Place of the value of r and h and simplify, you get 400 coins. Okay, next question. See, a cylindrical bucket, a cylindrical bucket 32 centimeter high, a cylindrical bucket 32 centimeter high, with radius of base, with radius of base 18 centimeter, is filled with sand, is filled with sand. Write out the question. In fair notebook, you should write today's date, question number one, and then you should copy this solution, and the question already been dictated to you. Second question I'm giving. Write this, and every day you should be doing this. Whatever questions are done in the class, that should be there in your fair notebook. Next question, write down. A cylindrical bucket, a cylindrical bucket 32 centimeter high, with radius of base 18 centimeter, with radius of base 18 centimeter, is filled with sand, full stop, is filled with sand, full stop. This bucket is emptied on the ground, this bucket is emptied on the ground, and a conical heap of sand is formed, and a conical heap of sand is formed. This bucket is emptied on the ground and a conical heap of sand is formed. Full stop. If the height of the conical heap is if the height of the conical heap is 24 centimeter, if the height of the conical heap is if the height of the conical heap is 24 centimeter, find the radius and slant height of the heap. Find the radius and slant height of the heap. Find the radius and slant height of the heap. Question is clear? Now see, what does the question say? The question says that there is a cylindrical bucket, that there is a cylindrical bucket, and this cylindrical bucket is there. So the cylindrical bucket is this is the cylindrical bucket, you can see, and the height of the cylindrical bucket is 32 centimeter, and radius of the base is 18 centimeter. This is 18 centimeter. So this is the height of the cylindrical bucket, and this is the radius of the cylindrical bucket. This all it is filled with sand, and this all sand is transferred on the ground, and it forms a heap, conical heap. Heap, you can understand? Yes. So all is collected at a place. So when it is inverted, so it forms a conical heap. And this heap has got the radius r, and its vertical height is 24 centimeter, and this is the slant height. Now the question is, find the radius and the slant height of the heap. The radius has to be calculated and slant height has to be calculated. Vertical height is what? No. Now, if you see this question carefully, then you will come to know that the volume of cylindrical bucket and the volume of the conical heap both are same, because the volume of sand has neither increased nor decreased. The volume of sand has neither increased nor decreased. So you see here that the volume of the cylindrical bucket and the volume of the heap, conical heap, both are same, isn't it? So what I will do, I will equate the volume of both of them, cylindrical bucket as well as the conical heap. These two shapes are different, no doubt, but their volumes are same. So you write down the volume of cylindrical bucket, volume of cylindrical bucket, cylindrical bucket is equal to volume of volume of cylindrical bucket is equal to volume of conical heap, conical heap. The volume of cylindrical bucket is equal to volume of conical heap. Now volume of cylindrical bucket is how much? Here you take the radius as small r, here height as h. Here you take radius as capital R and height as capital H, because they should be different, because both dimensions are different, so their radius and height should also be different. So here small r, here capital R, here small h, and here capital H. So the volume here of the cylinder is what? Pi r square h is equal to 1 by 3 pi. Volume of cone is 1 by 3 pi r square h. So radius is r square capital H. So here you see pi in here, pi here, they will be cancelled out. Okay. So you are asked to find out, here height is given but radius has to be calculated. So capital R square is equal to small r square into h upon upon this will be cross multiplied, so it will be 3 will be in the numerator here, and here h will be in the denominator. Okay, cross multiplication, simple cross multiplication has been done. So that equals to 3 into small r is how much? Smaller r is how much? You see, 18 centimeters, no? 18. We'll write here 18 centimeter into again r square, so that it will be again 18, and again it will be height is given as how much? 32. So into 32 upon here the height is given as 24. Okay, so here you see 3 ones are 3, 8 3 is 24, 8 ones are 8, 8 4 is 32. So r square is equal to 18 square into 2, 4 means 2 square. That is equal to 18 square into 2 square. So that is equal to what? Capital R square. So if you take out square root now, capital R will be what? 18 into 2. That is 36. 18 to the 36 centimeter. This point is clear? The radius of the heap is now how much? 36 centimeters. Second part, they are asking slant height. Slant height is equal to L is equal to slant height is equal to, you can see L is equal to square root of r square plus h square, r square plus h square for the heap. So what is r? 36 square. What is h? 24 square. You know how to solve it? You know how to solve it? Yes. So this equals to what? This will be equal to square root of 36 square. 36 square will be 1296. 1296, and this will be how much? 24 square will be 576 square root of this. So this all comes to be how much? 1872 square root of 1872. You solve this you will get 12 root 13 centimeter. So this is the slant height and this is the radius. So two answers are to be found out, this one and this one. Clear? Is it clear? Yeah. Hurry up, do it fast. Copy this.